Hi everybody, it's Leanne. I'm going to go over the 2.3 homework from this week, and as you can see, this is the 2.3 section, and you guys were to do I have them written down here, 1, 3, 4, 10, 18, and 19. So as you probably noticed, a couple of these are a good challenge, so make sure that you are taking the time to go through your problems to see what was done correctly, maybe where you went wrong if you did go wrong, and make those corrections before you turn your homework in. All right, in number one, first of all, I just want to say that if you're confused on this one, it's a lot like practice exercise number 1, so you could go back to that practice exercise and look at it a little bit more closely. All right, so in number 1, we are being asked to use a math drawing to explain why multiplying the numerator and the denominator of a fraction by the same number results in the same number. So we're looking at the idea of equivalent fractions here. And then you have to give a general explanation and illustrate it. So we're looking at 3/4, and that's equal to 3 times 3 over 4 times 3. We're just going to keep in mind that students might find it confusing when we multiply the number, yet we divide the parts in our drawing. So let's really be mindful of that word divide and possibly think about how we might use the word partition instead. So let's take a look. So if you see here, you could have a rod that's partitioned into 4 equal parts, like I've shown right here. And then 3 of the ones that I've shown are shaded. And then if we partition each of those parts into smaller parts, so each of these 4 parts I subdivided or partitioned into 3 smaller parts, then you can see that the shaded portion consists of 3 groups of 3. So let's rely on our definition of multiplication here. We can see visually that we have 3 groups of 3, and that the whole amount, or our unit amount, is now 3 groups of 4. So if you have 3 groups of 3, you have 9 parts, and 3 groups of 4 of the same rod partitioned gives you 12 parts. And so the size of the whole doesn't change, yet we are looking at what happens to the number of parts. All right, number 3. Number 3, we have to use the fractions 2/3 and 3/4 to describe how to give 2 fractions common denominators. And then in terms of math drawings, what are you doing when you give fractions common denominators? We're really going to focus on what changes and what stays the same. So here's what I wrote here. To give 2 fractions common denominators, we use a common multiple of the 2 numbers. So for each fraction, we multiply both the numerator and the denominator by a factor that will change the denominator to this common multiple. So for the fractions given, 2/3 and 3/4, this common multiple would be 12. So specifically, I've shown it here. So in giving the fractions common denominators, what we're essentially doing in a drawing is we're partitioning the parts of each fraction. So I'm going to multiply both the numerator and the denominator of 2/3 by 4 so that I can get 12, my common multiple. I'm going to do the same with 3/4 by multiplying the numerator and the denominator by 3 in order to get that denominator of 12. And so by doing this, the total number of pieces, this is really the key part to this question, the total number of pieces and the size of the pieces changed. So that's the part that changes. Again, it's the total number of pieces and the size of the pieces. But remember, the amount of the unit amount, or our whole, stays the same. And you can see that back in number 1. You can see where the size of the piece changes and the number of pieces change, but the unit amount, or the whole, stays the same. And that's the key piece for students to understand when it comes to equivalent fractions. All right, number 4. Number 4, we're looking at making a math drawing to explain why dividing both the numerator and the denominator of 6/8 by 2 produces the same number. And so we're going to see how division by 2 in both the numerator and the denominator is shown here. And we're going to try to attend carefully to the things that might be difficult for students. So lots of misconceptions can be built here, so that's why we try to rely on math drawings to really help conceptualize these ideas. So when we join together small pieces of the rod to make larger rod pieces, that's going to help here. So here we're going to join 2 smaller pieces to make a larger piece, because both 6 and 8 can be divided by 2. So here you can see that I've got the 8 smaller pieces, or here these 6 smaller pieces. But when we group the 6 smaller pieces into groups of 2, then this yields a total of 6 divided by 2, or 3 larger pieces. You can see those in my drawing here. And similarly, when we group the 8 total smaller pieces into groups of 2, then this yields a total of 8 divided by 2, or 4 smaller rod pieces. And so this is just another way for us to use division to show equivalence. Now we can see that 6 1/8, as shown in the smaller rods, is equivalent in size overall to our 3 1/4 in our larger rod pieces. Okay, let's go to the next one, which I believe is number 10, but I'm going to double check here. Number 10, 18, and 19. Yep, number 10. Okay, hopefully I'm not making you guys dizzy by going back and forth here. All right, so in number 10, we had to draw a number line and place equally spaced tick marks on the number line so that you can plot 1/3 on a tick mark without plotting 1. And then you're going to plot 1/3. But you'll notice that on this number line that we're given to work with, we only have 2/7. So we have a 0 and 2/7, and we have to figure out how to plot a third without putting a 1. So it might seem a little tricky, but here's what I want you to think. Sorry, I wrote so largely here. So we have 7ths and 3rds that are both falling on tick marks. So what we're going to do is we're going to partition the number line into 21sts. Before I read my reasoning here, I'm going to go actually down to my number line. So do you see that this is what we're given, this 2/7 and this 0. And we're asked to not plot a 1. So the first thing I'm going to do is I'm going to partition the distance between 0 and 2/7. I'm going to partition that in half so that I can find my 1/7. Once I have my 1/7, I know that 1/7 is the same as 3 21sts. So I'm going to partition my distance between 0 and 1/7 into thirds. So now I have 1 21st, 2 21sts, 3 21sts. I'm going to do the same between 1/7 and 2/7. So now I have a 4 21st, a 5 21st, a 6 21st, and hopefully you're figuring out that, oh, there it is. There's my 7 21st, which is the same as 1/3. So now I'm able to plot my 1/3 actually on its own tick mark without plotting a 1. If you want to look at my reasoning here, I think maybe I just described it a little better than I did here in the writing. All right, number 18 and 19, these are classics, and I will say you guys are going to see a problem like 18 or 19 for sure on your next quiz. So pay close attention. 18 is the gravel problem, 19 is the serving problem. These are really common types of problems where there's lots of room for kids to get confused, and the piece that's important is really attending to the whole or the unit amount. And so in the first problem, Ken got 2/3. Where are you? Here we go. Ken got 2/3 of what he ordered, and he ordered 3/4 of a ton of gravel. And you need to figure out what fraction of his order he received. All right, so let's take a look at this. First of all, I have this rod or the strip diagram that's going to represent 1 ton. And the first thing I'm going to do is I'm going to show his order. And so what I did here is, and maybe you can see that this right here, this amount, this 3/4, I have indicated as his order. He ordered 3/4 of a ton. And notice that I'm indicating the unit amount or the whole here with my strip diagram label, that's the 1 ton. Then he received 2/3 of his order, right? Is that what it says, 2/3 of an order? Let's go back and make sure I have the right. Yes, he received 2/3, no, he received 2/3 of a ton. So now I want to show that he received 2/3 of a ton. So what I've done is I've partitioned each of these fourths into thirds so that now I can see that he received, can you see where I've colored these? 2/3, here's our received amount. He received 2/3, also known as 8/12 because I partitioned each of my fourths into thirds. And so this is the amount that he received. And so the question is, how much of his order did he receive? Well, he received 2/3, he ordered 3/4, so he received 8/9 of his order. And what happened here is the unit amount or the whole changed. So look what happened. In the beginning, our whole is the ton. right? And so he ordered 3/4 of a ton. That's the unit amount. He received 2/3 of a ton. That's the unit amount. But then the question is, how much of his order did he receive? Now the unit amount has changed, and now our unit amount is right here. How much did he receive of his order? So now the order amount, the order becomes the unit amount. So he received 8/9 of his order. Gosh, I hope that makes sense to you guys. The last one is similar. It's another kind of problem where you really have to attend to the unit amount. So in 19, we have 1 serving of Snackos is 2/3 of a cup. Jane wants to eat 1/3 of a serving. So what's really important here is that you're already noticing that the unit amount is changing. 1 serving is 2/3 of a cup. There's the unit amount. She wants to eat 1/3 of a serving, right? There's going to be another unit amount. And then we're going to be asked what fraction of a cup she eats. So let's go to that. So 1 serving, you can see in my strip diagram, is 2/3 of a cup. So that means that in my diagram, this whole strip diagram represents 1 cup, because a serving is 2/3 of a cup, and I want to show how that relates to that unit amount. She wants to eat 1/3 of a serving. So what I did is I partitioned each of those thirds into thirds. So now I can show that she wants 1/3, which is 2/9 of this whole cup. She wants to eat 1/3 of a serving. So there's 1/3 of a serving. Here would be another 1/3 of the serving. This would be another 1/3 of the serving. So this chunk right here is 1/3 of a serving. But how much of a cup is it? So now we have to relate it back to that cup unit amount. So that's 2/9 of a cup. So if she wants to eat 1/3 of a serving, she needs to eat 2/9 of a cup. Oofda. I hope that helps you guys. Thanks for listening. Let me know if you have questions, and I'll look forward to it.